What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today we're going to be talking about alcohol nomenclature, okay? And this is going to be the IUPAC naming system. So the best way for me to start learning how to name new molecules is to start with practice problems. So let's go ahead and start with some practice problems. Okay, so I'll go ahead and draw some out for us. Okay, guys, so how do we name this molecule? Remember, in order to name any molecule, we want to try to find the longest carbon chain. Okay, think of it as naming, finding the biggest tree in the woods. You want to start with the base, the root, and you want to go all the way up, and then from there you want to see what's branching off of the tree. Okay, so here we can find our highest priority functional group is where we're going to start naming, or we're going to start numbering carbon number 1. Okay, so right here we see that we have this functional group here. Okay, this is a hydroxy functional group. Okay, now hydroxy is just another way of saying, it's an alcohol. Okay, so we're working with an alcohol. So if I start numbering here, this is going to be carbon number 1, 2, 3, 4, 5, and 6. All right, so coming off number 1 is our highest priority, which is our OH group, and we have a 6 carbon chain. And coming off of carbon number 2, we have a methyl group. So this is going to be a 2-methyl hexanol. Okay, so anytime we're naming alcohols, we take the base name. So we take hexane, we're going to drop, so this is drop the E to give us hexane, and then we add ol. Okay, so drop the E and add ol, hexanol. Okay, so that's how we're going to name. Let's go ahead and do another example. What if I drew this structure right here? We had a chloro group and an OH group. Okay. How would we name this group? Okay. So again, coming off of carbon number 1, we want to put our highest priority group. So this is carbon number 1, number 2, number 3, and then number 4. So I see that we have a ring. It's a 4-membered ring, so this is going to be let's do it in a different color. This is going to be a cyclobutane. Remember, we drop the E and we add ol, cyclobutanol. Right? Because if it was just a cyclobutane, it would be a 4-membered carbon ring. In this case, we have the alcohol functional group coming off of carbon number 1. Off of carbon number 3, we have a chloro group. Chloro. So we have a 3-chloral cyclobutanol. And if we were to do our RS stereochem, let's do our RS stereochem for carbon number 1 here. We have hydrogen group coming in the back. So we have highest priority group is number 1. Oh, in this case, we're actually not going to have any RS stereochem because if we try to find our highest priority group is number 1, our lowest priority is number 4. Number 2 and number 3 would be the same thing, right? Because if we come over here, we hit a carbon with an OH. Same thing over here, we hit a carbon with an OH. So we don't actually need any RS stereochem for this problem because this carbon here only has 3 different unique groups coming off of it, not 4 different unique things. Same thing here. This carbon here has the OH group, it has a hydrogen going away, and then it has this and this, but those are the same things. All right, so let's go ahead and try another problem. Let's put number 3. Let's go ahead and put another ring here. So how would we name this one? What do you guys think? This is going to be a cyclohexanol. Okay, not too bad, not too bad. Let's do another example here. What if I gave you this? And then coming off of here, we have that and this. What do you guys think this is going to be? Well, coming off of carbon number 1, we have a 1, 2, 3, 4, 5. Coming off of carbon number 1, we have our highest priority functional group, the OH, but we also have an ethyl group coming out in front. So this is going to be 1 ethyl cyclopentanol. Cyclopentanol, okay? Let's go ahead and do 2 more examples. So if I had, let's say I had number 5 over here, and I wanted to draw what if I drew this? Okay. Well, let's go ahead and try to find our longest carbon chain that's going to give us the highest priority group. And remember, we want to have the lowest number possible for our substituents. So if I start numbering from over here, I can do 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Let's go ahead and see. We can do, coming off of number 2, let's go ahead and draw in. Coming off of number 2, we have 2 methyls. So we can do 2, 2 dimethyl because we have 2 methyl groups coming off of that carbon. Great. Now, what about carbon number 3? We have a geometry, so we have to make sure we account for our geometry. We have to use our RS stereochem. So coming off of carbon number 1, highest priority group, number 1 is going to be the OH group. That's going to be number 1. Now we have to find our lowest priority group is going to be our hydrogen. Now we have to compare and see which one is going to be of higher priority. So let's see if we go this way, we hit a carbon, and this one is a carbon. Well, carbon 4 here only has 2 hydrogens and then another carbon. Carbon number 2 here has another carbon, but it has 2 methyl groups coming off of it. So this side will be third priority. This will be priority number 2. And then over here will be number 3. So if I do my RS stereochem, looks like it's moving in the clockwise direction. That's going to give me an R stereochem at carbon number 3. So the way this will be named is we put 3R, 2, 2 dimethyl, and then just because I'm running out of space here, we're going to put 3-hexanol, okay? Now, there would not be any dash right here if I had more space, but I'm only putting the dash there to show that there's no space between this 3 and this hexanol. Actually, we don't even need the 3 because it's already being represented with the 3R that we put out in front. That's great. Okay, and our last example, let's do last example here. This is going to be number 6. if I gave you this? How would you name this? Well, in this case, our OH group is not our highest priority functional group. In this case, the carboxylic acid is the highest priority functional group. So we start numbering from there, just like that, and then we try to find the longest chain possible for the number of carbons. So in this case, I actually see that my OH group is acting as a substituent. It's not acting as the highest priority. So we would call this a hydroxy group. This is a hydroxy when it's acting as a substituent. So this would be 2-hydroxy ethanoic acid. Okay? Now we'll talk more about naming carboxylic acids when we get there. But in this video, I just wanted to show you that the OH can act as a substituent, in which case we call it a hydroxy. All right, guys, thanks for tuning in. That's everything today for naming alcohols. See you guys next time.